Welcome back to part 2 of the MicroCraft to mini micro conversion. I have spent the last couple of days meticulously converting each of these Java files into mini-script files, one at a time, and I have not converted all of them. I got all the resources, items, tiles, entities. The only files left are these screen files and the level class. But I have converted enough of this code that it now runs. So that's something. Over here in the main class, you can see basically grabbing all of these classes, dumping them into the globals. And I had to do a funny thing here with this file called items. If you go up to the item resource folder, the resource Java file defines the resource class and the dictionary of resources. And some of those depend on tile definitions. Like the resource, let's see, I think it's that you can plant, yeah. Make sure I know what I'm talking about here. You can use an acorn as a plantable resource to plant a tree sapling. Okay. And if you go over to the tiles, in the base tile class, the tile class and the tile dictionary are in one file, and some of those tiles depend on resources being defined. Destroy the iron ore tile, you'll get some iron ore as the iron ore resource. So this is a whole mess of circular references that it worked in Java, it doesn't work in MiniScript. What I ended up doing originally was having the resources and tiles in separate dictionary files, but even that didn't deal with all the circular references, so I created this items file. This is basically generating all of the tiles and all of the resources after the classes are defined. Define the tiles that we can, and then you gotta define the iron ore resource before you define the iron ore. And some of these things, like you have to define wood and stone before you can define, no, it's not the wood and stone are fine. Things like how for dirt, you first, dirt resource, you first have to have the whole water and lava tiles defined. So there's a lot of back and forth here that, as I wrote here, I don't really like how these definitions are mixed, but it gets us up and running, so it's something. And like I've said in the last video, for this first pass, we're just trying to get all this Java code converted and running, and we'll focus on performance and cleaning up the code on the second pass. The main file, as of right now, if you were to go and grab a clone of my repository right now, it's just a little event loop that tests out the input handler. Let's review the input handler code again. This is a conversion from the Java code. These keys are actually, it'd be better to name them actions. There are 6 actions in the game: up, down, left, right, attack, and menu. But I kept the name of the class the same as it is in the Java code. Just as long as we're working on the conversion, it's best to have the code match the Java code as closely as we can get away with. So each of these keys tracks presses, absorbs, whether it was down, whether it was clicked. And there's a tick function that I have to call from the main loop. The main loop is actually from, I'm using the events library. I have an event loop defined in there that it has better correspondence to what the Java code was doing. But all of this just to test out, do the keys do what we expect? Can we test that these different buttons were clicked up, down, or down then up in one frame? You can see here there's some stuff like the MicroCraft code actually has something similar to the Minecraft code, in that if you fall too far behind on processing, it's going to try to figure out how many ticks it's missed, unprocessed ticks, and then process all those ticks at once to catch up. But if you run this code as is, then you can see that if you can press the keys and see the different actions get printed to the screen. The thing that, gotta break out. The thing I wanted to really focus on for this video was something I found in the level generator. If we go to the Java code, there's a lot of stuff here on the math required to generate a level. It's basically a level you know what, we'll do most of the code review in the miniscript file. But notice down here, there is a main function. This file was designed to be run separately. It looks like it will generate a level and then give a summary of that level in a little image that is popped up in a message dialog. So that's cool. That's something we might be able to get running right now, that's our goal for right now. Converted all this to miniscript, like all this, I got faster at it as I went along, but it's just really grindy. There's no really straightforward way. It's simple, but not easy. Each little step was easy enough, but it just like so many of them. The initial, when you make a level gen object, it fills up this values array with some samples. And then it does math on those samples. And then when you create, let's create top map. Let's look at that function. It's actually creating several level gen objects as different layers of noise with different, what's that third parameter? Feature size. And then it does some other math to combine those, which is interesting. Could not really tell you exactly where the original developer came up with all this math. I've seen Perlin noise generators used for this kind of thing, or what's the other kind? Simplex noise. But I'm not sure that's what's going on here. And it could be that he just developed it as he went along because it got the job done. But it generates a height map, and then depending on the exact height at each sample, it decides what type of tile to stick in there. And you end up with a map full of tile IDs. At the very end of level gen, you'll see that I've reproduced the main function. And if you run this by itself, it'll execute the main function. The problem is a lot of these types won't be defined. So well, let me show you. I think it's in level, then level gen, reset, run, level gen, undefined identifier random. Yeah, it's just one of the classes is missing. There's just too many dependencies in this whole thing, and like a Java project would link it all for you, but I don't want to stick the whole pile of imports from my main function into this file. So what I'm going to do is pull the main function out of level gen and stick it in my own main function, or main file. But how do we want to do this? The event loop is going to just respond to button presses and print them on the screen. There's nothing stopping us from dumping a pixel display behind that. I have a test level gen function. We're going to try to run it from here. Take that out. Oh. Make sure the level gen file is still returning the level gen class. I have not tested this file at all yet, so this will be the big test to see if it even does anything. One of the problems we're going to have to solve is that the Java canvas displays from the top origin at the top left, mini micro canvas origin is bottom left. So when everything goes weird, we're going to have to remember to invert the y-axis. Note to self for later. All right, let's run this and see what kind of errors we get. Oh, well, the first problem is that we're in the wrong folder. go. Reset. My main. Unidentified identifier. Main is unknown because I renamed the function. Let's do that. W is unknown in this context. Level gen line 63. Okay, let's find line 63. And yeah, problem is I replaced all the this keywords from the Java code with self, but because this is not required, there's some of these variables that I just missed. Yeah, we'll just find it as we go along. All right. Okay. Level gen line 176, could not find ID. For the water tile, let's make sure our water tile is actually doing what it should be doing. Tiles, water tile. Yeah, here's another problem. My constructors need to return self, and there's some that I missed. Waiting. Level gen line 230, could not find ID, is probably the same class of error. Flower. Where is the flower tile? Yep, same problem. And this needs to be self.connects to grass. That's actually a huge problem. Again, no, it's a Java file. I need to not change the Java code. Okay, I think that accounts for all the others. Waiting. Set pixels unknown. Line 207. So back to our main file. 207. I keep wanting to put a pound sign there. Okay, so that, just want to make sure I'm doing that right. Switching languages, I get mixed up. Oh, do you see what I see? That down there is our map, at least for the overworld. Okay, so we're going to play with this a bit. The rendering actually went reasonably fast. We're going to make it faster later on. Control C out of there. I'm gonna try to scale this up. Trying to remember function for filling a rectangle. It's little things that will flee your mind when you're on video. Pixel display. Fill rect. Left bottom width type color. And we're going to do it like this. Left bottom width height color. Let's make sure that still works. Two, 3, 4, 5, 6, 7. So it takes 7 seconds to render. It's still tiny. Let's make it bigger. Scale it up by 3. 1, 2, 3, 4, 5, 6. That's not bigger. Okay, what'd I miss? Oh, let's multiply that out also. One, 2, 3, 4, 5, 6, 7. All right, that's a little better. I think we can make that 50% bigger. Oh, what is 3 times 1.5? That's actually the same as 3 plus 1.5. I want to fill the screen as much as I can here. It's probably good enough. Oh, I don't like those lines between my rectangles. We can get around that by doing, probably just by adding 1 to both of those. There you go. There's the overworld. All right, now we can hit the left and right buttons, or up and down. I want to use up and down to control what level we're on. So, how are we going to do this? Say our current level is 0. And the underground map has a depth. Sky map does not have a depth built in. So we're going to convert this from the test level gen to render level. We're going to pass in the level number. And then we need to basically have a bunch of if statements to determine which type of level to generate. How far does this go on depth? Create underground map. How is depth used? Anything greater than 2 for the depth will draw lava in place of water. If it's less than 3, then it does some stuff here. I wonder how far down it goes. We're going to say that the sky is -1. this. If you're at -1, create and validate the sky map. Otherwise, create and validate the underground map. We're going to pass in whatever level number makes it to this function. This will be a great test to make sure that I converted all of the code correctly. Then if you hit the up key or the left key, we subtract 1 from the level. And we'll disable these 2 keys for now. They don't gain us much. The global's dot, otherwise it's going to create a local level variable. Pretty sure. Yeah, I'm pretty sure I need to store that in the globals. Call render level instead of test level gen. When we're rendering the level, print out the level number at the bottom of the screen. And we actually need to call it now. All right, let's test it. Oh, W's unknown, level gen 963. Yep. Oh no, that didn't come out the first time. Okay. And again. I have to do something about that wait time. Okay, so what level are we on? Oh. Okay, we need to fix that. Printing should work. Why didn't it? Hate it when my stuff just quietly refuses to work. Yeah, you're gonna find a lot of code here that is not quite standard miniscript code. A lot of extra parentheses and stuff. it's going to get cleaned up. I, can't do everything perfectly all at once. It takes time. Beautiful art takes time. I'm gonna print this at the end just to be sure. Oh, it's because I print it and then immediately clear the text screen. Well, that makes sense. And it should be starting us on level 0. Which should be the top map. But it's oh, it's null. We're passing in a null. There we go. Rerun. All right, and I am being a little OCD. I want that text at the top of the screen. How many rows on this display? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's about 26 rows. Cool. Just I'm putting together a little demo so that you all can play with the level generator. I want it to look good. It's not really fast, but it'll look good. All right, so level 0. Gonna hit the up button to look at the sky map, and that's the sky map. Sky map is filled with clouds, cloud cactus tiles. These black areas must be the parts where you step on it and fall to your doom, and the white ones might be staircases. Back down to the top level. It's going to generate a new one each time because we're not caching any of these when it generates, for better or worse. Now we're going to go down a level. Well, you can see water, desert, forests, mountains, and there's staircases in the rocks. The white pieces must be staircases. I'm not sure what the black is. Cactus. Going down. Waiting. Okay. So that's the first cavern level. You go there to get iron. Somewhere in this map is a staircase. It's not really clear. Going down again. Each time you go down, there's a different level of ore you look for. Build the next level of armor. Go down a level. Get more armor. Level 2. What level generates lava? Has to be greater than 2. Let's go down again. Level 3. Cool. So where's my lava? I think this part out here is the lava, but is it even rendering it? Lava set cells is like red, green, blue. I guess it's not really clear. Hopefully it'll get more clear when we start rendering the full screen to be looking around. Like I said, all this is a work in progress. Oh, wait a second. Create validate underground map. I'm not calling that correctly. This function is different from the others. It takes 3 parameters: width, height, and depth. Let's throw a level parameter in there. I betcha that will change something. Alright, going down. There's level 1. Why is there so much water? I don't know, maybe there's supposed to be water. interesting. Going down another level, level 2. What do we have on level 2? Okay. Going down to level 3. Waiting. Oh, there it is. There's our lava. Wow, that's a lot of lava. I guess you're going to want to be careful digging into that layer. Okay, this is cool. So, we have two things working in here. We have the input handler is processing the keys the way it should, and we pulled the level generator, the code to test the level generator out of the level gen file and created a little demo based off of that, which that's already giving us something to root around with for performance increases. There's so much code in here, it's going to take some time. I'm sure there's a way to make this faster, or at least generate a progress bar. We're just going to have to live with it for a while. Nothing is really throwing itself in my face as being an obvious place to slow down, except for the fact that there's like 4 loops in 4 loops followed by more 4 loops, and there may or may not be anything we can do about that. Good news is, when you're playing the actual game, you only have to generate these levels once at the first time you enter a level. Okay. So I'm going to throw this code up to the Git repository. And I'm going to remind you all, go to my GitHub account, MicroCraft. You can clone this repository, and you should be able to run the same demo you just saw me run. The link will be in the description. And if you have not already, subscribe to the channel and you'll get these updates pushed out. I'm expecting this project to be really exciting. Going to hopefully have a really great demonstration on how to convert and optimize Java code to run efficiently in the mini micro environment. And that's my favorite kind of project, really, because in order to do a conversion that with a decent performance, you have to have a fairly good level of understanding both of the system you're converting from and the system you're converting to. So I think this is going to be fun, and hope you join me again. See you later.